Welcome to the DIY Honda Garage channel. The diagnostic trouble code, DTC P1707, relates to a low-voltage condition within the neutral position sensor B circuit of the 2016 Honda HR-V. This component is critical as it informs the powertrain control module, PCM, about the transmission's gear position. Accurate information from this sensor is essential for optimal performance, safety, and engine management. The neutral position sensor is located on or near the transmission, connected to the transmission control unit through a 4-pin connector. A persistent low-voltage condition can trigger various symptoms, including transmission malfunction and possible failure to start. Addressing DTC P1707 promptly is crucial to maintain the vehicle's drivability and longevity. The neutral position sensor B circuit is integral to the overall operation of the Honda HR-V, specifically relating to gear positioning and transmission control. When this sensor detects low voltage, it indicates that there is likely a problem in the circuit leading to the powertrain control module, PCM. This sensor helps in reporting the position of the gear, such as park, neutral, or drive, which assists the PCM in managing engine performance, emissions, and fuel efficiency. The sensor is typically located on the transmission assembly and connected via a 4-pin wiring harness. A proper functioning neutral position sensor ensures that the vehicle operates correctly under various driving conditions, and any malfunctions can hinder performance. There are several potential reasons for DTC P1707 appearing in the Honda HR-V. One primary reason could be a faulty neutral position sensor itself, which may not effectively signal the PCM. Alternatively, issues such as an open wire in the circuit can disrupt the voltage flow, thus triggering this DTC. A shorted wire condition can also occur, causing an unexpected drop or rise in available voltage. Furthermore, poor connections or loose terminals, particularly at the sensor or PCM connections, can lead to intermittent issues, causing this error code to be displayed. Each of these causes needs careful examination to determine the necessary repairs accurately. The presence of DTC P1707 can lead to various symptoms impacting the overall performance of the Honda HR-V. You may experience a noticeable transmission malfunction where the vehicle may not change gears properly. Poor engine performance is another likely symptom, as the inadequate signaling from the neutral position sensor may disrupt fuel efficiency and torque delivery. Additionally, the vehicle might fail to start, potentially leaving the driver stranded. Another critical symptom includes unresponsive gear shifts, where the driver might find that shifting between drive, neutral, and reverse becomes delayed or ineffective. Addressing these symptoms is essential to ensure a reliable driving experience. The first step in troubleshooting DTC P1707 involves a systematic approach to gather clear diagnostic information. Begin by turning the vehicle's ignition to the on position, ensuring that all electronic systems are active. Utilizing the Honda Diagnostic System, HDS, you will need to clear the existing DTCs. After clearing, it's crucial to check for either pending or confirmed DTCs with the HDS once more. This helps in verifying whether DTC P1707 is still present and indicates that the issue requires further investigation. If the DTC does not reappear, it suggests that the system was temporarily faulted, and you might need to inspect for poor connections or loose terminals. In this second step of troubleshooting, you need to confirm the presence of DTC P1707 or any other related DTC. Using the HDS, check for both pending and confirmed DTCs. Specifically, look for DTC P0851 and DTC P1707 appearing simultaneously. If both codes are present, which indicates a potential linkage in the issues affecting both the A and B sensors, you should proceed to the next step. Otherwise, if only P1707 is present, it suggests that the problem may be specific to neutral position sensor B, leading you towards further diagnostics. Being thorough at this stage ensures accurate assessment and appropriate action. In Step 3, you will investigate the electrical components associated with DTC P1707. First, turn the vehicle's ignition to the off position to ensure safety while working on the electrical system. Next, disconnect the neutral position sensor's 4P connector for testing. With this connector detached, turn the vehicle back to the on mode and prepare to measure the voltage at the sensor's connector. Measuring voltage between the terminals should provide clear insight. Approximately 5 volts indicates proper function. A finding of sufficient voltage indicates that the sensor is likely malfunctioning and may need replacement. This step is crucial for isolating the issue within the sensor circuit. Step 4 focuses on the integrity of the VCC2 wiring, which supplies voltage to the neutral position sensor. Ensure that the vehicle is off and jump the SCS line using HDS to prevent accidental airbag deployment. Then, disconnect the PCM connector B to facilitate testing. With both the neutral position sensor 4P and PCM connector B disconnected, you should now check for continuity between terminal 29 of the PCM B connector and terminal 1 at the neutral position sensor connector. A positive continuity test confirms that the VCC2 wire is functioning. If insufficient continuity is observed, you will need to look for and repair any open circuits in the VCC2 wire, which may remedy the low voltage issue. In troubleshooting Step 5, you re-examine the functionality of the neutral position sensor. Start by turning the vehicle off, then reconnect the neutral position sensor 4P connector to allow the HDS to check its operational parameters effectively. Once the vehicle is turned back on, verify the output signal from neutral position sensor B using the HDS. Specifically, check if the sensor is reporting approximately 5 volts. If it is within range, this confirms that the sensor is likely the cause of the DTC P1707, warranting its replacement. Conversely, if the output is still inadequate or not indicating the expected value, this suggests that additional troubleshooting might be necessary to explore other potential issues related to the sensor circuit. The 6th troubleshooting step is essential for ensuring that wiring integrity is maintained, particularly for the NSS2 wire. Begin again by turning the vehicle's ignition to the off position to ensure a safe testing environment. Jump the SCS line using the HDS to prevent any accidental airbag deployments. Disconnect the PCM connector B to perform continuity testing. You will need to measure continuity between terminal 4 on the neutral position sensor's 4P connector and the body ground. If continuity is confirmed, the NSS2 wire is functioning properly. If there is no continuity, it's necessary to identify and repair any shorts in the NSS2 wiring between the PCM and the sensor connector. Final verification is key after performing repairs associated with DTC P1707. Begin by confirming all repair actions taken, ensuring replacement of the neutral position sensor if necessary, and resolving any wiring issues. Once confirmed, use the HDS to clear any outstanding DTCs from the system. After clearing, run the vehicle to check for normal functionality of the transmission and to ensure that no new DTCs appear. This follow-up is essential to confirm that the initial problem has been effectively addressed. An absence of the DTC post-operation signifies successful troubleshooting and repairs. Preventive maintenance is crucial to avoid future issues tied to DTC P1707. Regular inspections of wiring, connectors, and sensor performance can help identify problems before they manifest as DTCs. Ensuring that the electrical connectors associated with the neutral position sensor are clean and free from corrosion is key to maintaining good connectivity. Monthly checks can help in identifying any loose or damaged wires, preventing larger issues down the line. Besides physical inspections, keeping the PCM software updated with the latest versions from Honda can help in preventing and resolving sensor issues. Regular maintenance routines contribute significantly to the vehicle's reliability. In summary, addressing DTC P1707 involves the systematic approach, requiring thorough troubleshooting and verification processes. It is vital to first confirm DTC presence and then check the voltage output from the neutral position sensor. Key areas of focus include the wiring integrity and potential shorts within the circuits related to the sensor. If a faulty sensor is confirmed, prompt replacement ensures smooth operation. Additionally, implementing preventive maintenance routines aids in avoiding recurrence of the issue. Overall, attention to detail in diagnostics and maintenance directly correlates with long-term vehicle reliability and performance. Please like and subscribe to the channel. See you next time.